Goal this time is we're going to be able to use the quotient rule. Quotient, of course, is when you divide two things. To find the root of a simple rational function, we're going to understand that rational functions can be rewritten as products of functions and can be differentiated using the product law or the power law of a function rule. So, as with many other things in math, and this is no exception, sometimes there are different routes to getting the answer. It's not like you have to do everything one way. Math is not as rigid as other subjects. No disrespect to any of the other subjects that you're doing, or any of the other teachers that you have. But math is very flexible, right? There is no one rule that says things have to be done one way. You can find different routes of getting to the same destination, which is why I love the subject. Okay, so let's get to it. Let's get to it. Last time when we looked at products, we were able to show that if we had a product, taking the derivatives of each of the parts of the product and then just multiplying those derivatives did not work. Would it work if it was a quotient though, right? Y equals 3x to the power of 4 divided by x squared, right? Would it be okay for me to just find the derivative of the top and then divide it by the derivative of the bottom and then we're good? What do you think, folks? It didn't seem to work out so well with products. You think it's going to work out with a quotient? If you had a guess, what would your guess be? If I were to find the derivative of a quotient, you don't think so. Well, I'm here to tell you it doesn't work, but let's just prove it doesn't work. The fact is that 3x4 over x squared, as you can obviously appreciate, is the same thing as 3x squared. The derivative of 3x squared, of course, would just be, so dy dx of this would be equal to 6x, whereas this, the derivative of the top would be 12x cubed. The derivative of the bottom would be 2x. And when you divide those out, you're not going to get the same thing as what you got over here. So, does not work. Let me just sort of lay that out. Didn't work for a product, it ain't going to work for a quotient. So, Anika is right. So what will work for a quotient? Well, let's see. Without me proving why it does work, let me show you what does. The quotient rule says that to get the derivative of a quotient, if I'm going to use Leibniz's notation, so dy dx of u divided by v is the derivative of the v minus the derivative. Well, let's look at the first one up here. This the top one might make more sense. Find the derivative of the top, which is the f of x function, multiplied by the underived bottom, right? So that's the g of x, minus the underived top times the derived bottom all over the bottom function squared. Not derived, just the bottom function squared. Of course, the g of x cannot be equal to 0. Let's just be clear on that, because since it's a quotient, then you know that you can't divide by 0. So you have to restrict the x values that would give you 0. Okay, so in this particular case, right, we first of all noted that if I were to simplify this, right, this would be equal to 3x squared, right? If I were to just, use the principle of subtracting exponents from each other, that would be 3x squared. And the dy dx of this, therefore, would be equal to 6x. Well, let's apply that quotient law to this. The quotient law says, take the derivative of the top. The derivative of the top of this, so this is the dy dx now. Should be equal to the derivative of the top, which is the 12x cubed, right? Multiplied by the x squared, so the underived bottom, minus, remember it's minus this time, not plus, the last time it was plus, and the order in which you minus matters, so please make sure you do it this way. When we were doing the products a while ago, it didn't really matter which product you took first, because when you add them up, you get the same answer. But in this case, it does matter. So start off with the derivative of the top times the underived bottom, minus the other way around, which is 2x times the 3. So we've derived the bottom, we're going to multiply it by the underived top. So that would be times the 3, I put it in brackets actually, 3x to the power of 4. And we're going to divide all of that by the x squared squared. Okay, so where did the 12 come from? Oh, and you're okay now with it. Okay, good. All right, so let's keep going. Because remember, our goal is to end up with the 6x. That's what we expect to get from all of this, right? Because we're saying that if you just simplified this, it would just be 3x squared, and that's just simply 6x if you were to derive it. So let's keep going. So this first one here is going to give us 12x5 minus, this looks like 6x5, right? Again, I'm adding exponents together, divided by x squared squared is x4, right? You multiply the two exponents together. Well, we can tidy this up some more. This is a like term, so that should be equal to 6x5 divided by x4. And of course, that works out to be just simply 6x. You subtract again exponents, so 5 minus 4 is just simply 1, and then the 6 is left. And guess what? Same answer we got the first time. Over here, same answer we're getting down here after you've simplified it down to its lowest terms. So this quotient law does seem to work. In this case, we didn't have to really use the quotient law because we had a simpler way to do it by just reducing it. And I wanted to sort of say that to you. There are times when you shouldn't overcomplicate things, right? If there's a simpler method to getting something done, then use it. Well, that's my approach anyway. I'm looking for the shortest, least complicated way to get anything done. In this case, just simplifying it and then applying the regular rules of derivatives would make more sense than using the quotient law. But I showed you, though, that the quotient law and the simplified form still end up in the same place. Okay? All right. Let's use a shortcut now for this. So, remember now that we're using the quotient law. We could have done this without the quotient law by doing what we did the last time, make it into a product, but we're going to use the quotient law this time. So the quotient law would say that f prime x would be equal to, let's put it over a fraction here, the top derived, which is 1, multiply, I don't really have to put the 1, but I put the 1 just the same, times the 2x minus 1, minus the bottom derived, which is 2, times x plus 2, all over 2x minus 1 squared. All right, let me go through that again. Derive the top, which gives me 1, multiplied by the underived bottom, so that's 2x minus 1, minus, because that's part of the formula, minus the derived bottom, which is 2, times the underived top, which is x plus 2. Obviously, I would expect you to simplify this. So the top would become 2x minus 1, and you multiply by 1 doesn't do anything, minus 2x minus 4, all over 2x minus 1 squared. Okay, so minus 2 times x, minus 2 times 2 is minus 4. And obviously, I would expect you to simplify this down to minus 5 over 2x minus 1 squared. And there's your derivative. Okay, I can absolutely do this using the quotient law. I could use the product law, but I'm using the quotient law in this case. We're going to show now that the product law and the quotient law can be applied equally with the same result. So let's go back and use a product rule on this question. What would this look like if I was writing this with the product rule? Can anybody give me a way of writing the left-hand side. We'll get to the right-hand side later on. Is there a way I can write the stuff on the left using that product law? Can you suggest a way that I could write the stuff on the left so I could use the product law? I can't use the product law now because it's a quotient, right? Give me a method, give me a way that I could rewrite that so I could use the product law. Can you suggest something to me, please? Anybody? Any suggestions as to what that might look like? I'll just give it a chance here. So I'm going to raise to the -2, you're saying. Well, kind of, sort of, but there's a 5 in front of that as well. So what am I going to do with the 5? Because the 5 is not being raised to the power of 2. So what do you suggest I do then? So you think that I know why you're saying -2. You're thinking of the denominator raising to -2, but the 5 is there, and I need to do something with that 5. So how else can I? All right, let me show you what I'm thinking of then. So I'm going to rewrite this as the 4x3 minus 5, and then the 5x to the power of 2 to the power of -1. Theoretically, what I got, there's another thing I could have done. I could distribute that -1 into, because this whole thing is being raised to the power of 1 right now. So I can raise that whole thing to the -1. So what I could do is this, to sort of follow what you're saying. I could regard this as being 4x3 minus 5 multiplied by 1 over 5 times x to the -2. So that I can do as well, as long as I recognize that the 5 itself also has to be raised to the power of -1, right? Which is the same thing as 1 over 5, by the way. All right? So hopefully that part makes sense. All right? Did I leave anybody behind there? Does that all make sense? I'm using the product law now. I'm about to use the product law. Are we good? Okay. All right. Okay. Ashvan says he's okay. How about everybody else? Everybody else okay with that? Do I have to call names? I just want to make sure that everybody is fine with it. Okay, Anika, great. All right. Okay. Okay. I'll keep going. So according to the product law, let me give myself some more room here. So the dy dx now should be equal to the derived first one, which is the 12x squared, multiplied by the 1 over 5 x to the -2. I'm not deriving that part. Then I'm going to add to that the derived second one. Now, think about that -2. So it's going to be -2 over 5 x to the -3 times 4x cubed minus 5. All right, let me just go through that again with everybody. I'm deriving the first bracket, so that's the 12x squared. I'm not deriving the second bracket, so that's still 1 over 5x to the -2. Then I'm adding on to that, because it's a product law, I'm adding on to that the derivative of the second one, so that's the -2 times 1 over 5, so -2 over 5, x to the -3 times the underived first one, 4x to the power of 3 minus 5. Okay? So, yes, I'm expecting you to do more. This one here, the first one, I can combine these two coefficients to give me 12 over 5. X to the power of 2 times x to the -2. When you add those two together, what are you going to get when you add those two together? When you multiply the x squared times the x, you're going to get 0. You're going to get x to the power of 0. Let's just put it that way, which is 1. All right, I should say it that way. The second one, I'm going to put minus here because essentially this should be a minus, right? I'm multiplying a positive by a negative, so it really should be a negative. Negative 4 times, so that's -8 over 5 right? Those two, oh, actually, no, because I'd have to distribute this. I'm distributing this into the bracket. So minus 8 over 5, and then the x to the power of minus 3. So that would be, I guess that's 1 again, right? Then I'm going to multiply. Then I'm going to multiply that by the second one. And that's a minus times a minus. That's going to be a plus then. So plus, let's see now, that's going to be plus 2 times x to the minus 3. I think I did that right. Let me just double check that. Minus 2 times the 4 gives me minus 8 over 5. X3 times x2 is going to give me 1. And we'll multiply that by the second one. So that's minus, plus rather, plus 2 times x to the minus 3. Yeah, I believe that's okay. All right. And if I tidy this up now, I'd have 12 over 5 minus 8 over 5, and then plus the 2 over x to the power of 3. Okay? And I should try to put that as one common factor, which should be 5x cubed. Hopefully that common factor makes sense, because there's 5 here, there's 5 here, and there is an x cubed here. So that should leave me with 12x cubed. Actually, I should have brought, you know what? I should have brought these two fractions together. I don't know why I have two separate fractions here. Let me do one more step with this. Let's just do one more step with this here. Both of these fractions are the same denominator. So that should give me 12 minus 8, which is 4 over 5, plus 2 over x cubed. All right. Am I losing anybody here? Let me know. All right. Let me know. This is just algebra at this point. And then my common denominator here would be x cubed. And then, sorry, 5x cubed, that is. Then top of this would be 4x cubed plus 10 over the 5x cubed. So 4x cubed plus 10 over the 5x cubed. All right. Now, one way that we could be sure that this is right is by doing this again using the quotient law. And hopefully we should end up with the same answer. Hopefully we should. And if we don't, then we made a mistake somewhere. So we're going to use it. So this was using the product law, right? What we just did is using the product law. Gets a little scary as you go through some of the steps, but let's try this with the quotient law now. So let me copy this down. And let's go through the quotient law steps. So same function, but now trying a different strategy. And we're hoping that we end up with the same result, unless we made a mistake. So the dy dx of this should be equal to the top derived, which is the 12x squared multiplied by the 5x squared underived, right? So the top derived, 12x squared, this is going to go to 0, times that, minus 10x multiplied by 4x cubed minus 5, all of that over 5x squared squared. All right, hope I'm not losing anybody here. Let's try to tidy this up now. So this looks like I'm getting 60 x4, 12 times 5x out, 60x4 minus, I'm going to FOIL this out, so that would be 40 x4 plus 50x, I think. Let me just double check that. So minus 40x4 plus 50x, okay. All over 5x squared squared. Okay. Let's simplify the top. So I'm getting 20 x4 plus 50x. Okay, we just make sure that's 20x4 plus 50x, all divided by, I'm going to multiply this out now. I'm going to multiply this out to give me 25 x4. Now, can this be simplified some more? Is there any way that we could make this a little bit simpler? Any suggestions as to how this could be simplified some more? What do you think, folks? Any way that this might be made a little bit simpler? 20x4 plus 50x over 25x to the power of 4. There must be something we can do to make this a little bit simpler. No suggestions at all? What do you think? Anything at all? Cancel? Well, we can't cancel yet, Elisha. We have to factor out first. Yes, let's factor out, in fact, more than just 5. I think we can factor out 10. Right? We can factor out a 10x, can't we, out of the top? So if we factored out a 10x, we would get 2x cubed plus 5x, I'm thinking, over 25x4. And if you're thinking this is a lot of work, it is, but I do expect you to have the kind of skills at this point to be able to do this. At any rate, let's keep going. So what I have is factoring out 10x, I'm left with 2x cubed plus 5x. That sounds about right. And now I can cancel down. I can take one of the x's on the top, right? Which leaves me with an x cubed here. And I can also reduce down the 10 and the 25. 5 into that gives me 2, and 5 into this gives me 5. So what it looks like I'm getting, and then we can compare the two in a second. What it looks like I'm getting is 2 times 2x cubed plus 5x over 5x cubed. How does that compare to what we got before? Let me just make sure. 2 times 2x cubed plus 5x. Okay, what did we have before? We had 4x cubed plus 10 over 5x cubed. I think that's the same answer. It's just that we didn't factor out the 2 up here that we could have. In fact, let's just do that right now. So 2 into 2x cubed plus 5 over 5x cubed. All right, plus 5x. So hold on, what did I do wrong here now? Is there something missing here? Plus 5. Oh, nobody pointed out it's not 5x. Thank you. Thank you very much. And I was the one here in the chat. Yes, thank you. Let me fix that very quickly. Yes, let's take that out. And let's take that out. You're absolutely right. You're absolutely right. In fact, here that's how we know that we had made that we made a mistake, because we weren't getting the same answer. Not exactly the same answer. Thank you. All right, so it should have been 10x into 2x cubed plus 5. Absolutely. Absolutely. And then this becomes 2x cubed plus 5 times 2 over 5x cubed. Same thing that we had up here, except we didn't factor out the, yeah, thank you. Thank you very much. I appreciate you making that. Yes, thank you, Sarah. Thank you. And thank you, Adam. Appreciate that. Okay, anyway, the main point of that exercise was not to bore you stiff, but just to show you that quotient rule and product rule end up being the same place. And the fact is that when we saw that there was a difference, it meant that we just had to fix our math. Our math was, well, not me. Let me take the responsibility for that. My math was off, not yours. Yours was fine. Mine was the one that was off. Okay, now let's see if we can put some of those keen mathematical skills to work. Find the equation of the tangent to the curve at its y-intercept. At its y-intercept. Okay. First things first, we obviously need to find the derivative of this function. So let's go ahead and do that. The dy dx. So according to what we've been doing, the derivative at the top is 2x multiplied by the underived bottom, so 2x plus 1 squared, right? Minus the derivative of the bottom. Now, the derivative of the bottom, remember, would be 2 times 2x plus 1 to the power of 1 multiplied by 2, because then I have to multiply, and then I have to find the root of the inside function as well. All right? So let me do that again. 2x times 2x plus 1 squared. I'm not deriving the bottom. I'm going to derive the bottom now, which would be 2 times the 2x plus 1 to the power of 1 times the 2 of the inside function. And all of that is over 2x plus 1 to the power of 4, essentially, because we're going to be squaring something that's already squared. So it's 2x plus 1 to the power of 2 to the power of 2. Okay? So 2x plus 1 to the power of 4. Now, again, here's one of the cases where I don't necessarily, well, let me ask you this. What would my next step be? Do I really want to simplify this? Remember, I want the equation of the tangent to the curve at its y-intercept. What do we know about a y-intercept? Right? What's the thing that we know about a y-intercept? What's the special feature? If I give you a function that said find its y-intercept, I know that x is 0. There you go. Thanks, Adam, and thanks, Ashvan. So really, I'm not going to spend a lot of time trying to simplify this function because it's not necessary. The question was to find, the question said find the derivative and simplify it, and I would. But I really don't need to, because I'm going to use the derivative right now and plug 0 into the derivative. So I'm going to find f prime of 0. Why 0? Look at what Adam and Ashvan said. If it says the y-intercept, I know that at that point, at that particular x value, right, the x is for the y-intercept to be the y-intercept, it must be where the x is equal to 0. So I'm just going to plug 0 into the derivative because that's where I want to find the tangent. So I'm going to go ahead and plug 0 into this. Well, guess what? This whole thing here becomes 0, right? Then the second one, you're going to have a 0 here. So that's going to be equal to 0 plus 1 times 2, which is 2. So it's going to be minus 4, basically, is what I'm getting on top. Right? And then on the bottom, if I put 0 into that, it's just going to be 1 to the power of 4, which is just simply 1. Don't you have to multiply the top by x squared minus 3? Let's see if I did. Let's see if I forgot to do something here. X squared. Oh, hold on. I think you might be right about that. Hang on. I might have left something out. Yeah, I think you might be right. Thank you. Who is that? That's Taj. Okay, Taj. Let's see what I did wrong here. So, yes, absolutely, yes. Taj is making a very good point that I left something out of this numerator, which is probably going to change my answer down here. So let's get back to it here. I should have, after I derived the denominator, which is perfectly correct, I should have put the x squared minus 3 here as well, the underived top. So let me double check that I've now done it right. And thanks again, Taj, for pointing that out. So the root of the top, which is 2x, times the underived bottom, which is that. The root of the bottom, which is 2 times 2x plus 1 times 2 times the underived top, so x squared minus 3. Yeah, that's fine now. Okay, so let's get back to putting in 0 into this. So the top here, this first part is going to drop out. That's gone. Putting 0 into this, let's see what happens when I put 0 into this. There's a 0 here, and there's a 0 here. So I'm going to end up with minus 2 times 1 times 2, which is minus 4, times minus 3. So that should be 12 in that case. Okay. So that's going to be 12 over 1, which is just going to be, of course, 12. Right? The bottom is just going to be 1 to the power of 4. All right. Anything else that anybody noticed that Mr. Camel kind of messed up on? That's a good call, Taj. I keep complimenting you for that. Is everybody comfortable with what we've got so far? That the 12 makes sense? It's minus 2 times 2, sorry, times 1 times 2 times minus 3. Because we're just plugging in 0 now. Just plugging in 0. All right. So my slope of this function at that point is 12. Absolutely 100%, unless I did something else wrong, is the slope of the function at that point. But what do we do next now to figure out the equation of the tangent? We've done this a couple of times for equations of tangents. What's that next step again that we have to do to get the equation of the tangent? We have the slope, find f of 0, and not this, and Sarah's right, it's not the f prime of 0, it's the f of 0. I'm going to put 0 in the original function, right? Not f prime. And this looks like it's going to work out to be, that's at the bottom is just simply 1. The top is going to be minus 3 over 1. So minus 3. I'll double check that since I've made so many mistakes already. 0, so that's minus 3. And that's 1 square. Yeah, that looks like minus 3 to me. Okay, everybody else get minus 3? Did y'all get minus 3? Is that what you got? Hopefully you're doing this for yourself. Did you all get minus 3? Yeah, yes, Sarah, thank you. Anybody else get the same thing as that, what I just got, minus 3? Does that make sense? Wait, where is everybody, by the way? 12x, oh, you're jumping ahead of us there. Okay, so yeah, that is the one step. So you're right, Danny, because we really even don't need to do a lot of steps. We know that the function value is 0 minus 3. And yes, if I put y equals mx plus b, I'm going to get minus 3 is equal to 12 times the 0 plus b. So that means that b is equal to minus 3. So my tangent line is what Danny just said. Y is equal to 12x minus 3. Okay, good stuff, good stuff. Your turn. I want you to go through all those steps to find the equation of the tangent, everybody, okay? So I can call in anybody and expect to get an answer. And hopefully you're not going to make the kind of mistakes I just made, by the way. Find the equation of the tangent line to this function at x equals 0. So again, using 0, because that's just a convenient number to use, I'm going to stop. I'm going to mute my mic and give you some time to work on this for yourself. It's the same thing I told you the other day, personal trainer analogy that I always use. Watching me do it is not going to make you learn as much as when you do this for yourself. So let's start with Taj. Taj, you're up next. Tell me what you have as, we'll get to the actual answer later on. Tell me what you have as your derivative first of all. Give me what you said was the dy dx of this function. As simple as you can come up with it. What's your dy dx, Taj? And by the way, obviously, if you wanted to just unmute and say what you have, that might be easier for you rather than trying to type it in, but that's your choice. I haven't gotten to the actual answer, but in terms of derivative, okay, I'm going to write down exactly what you have here. So minus 2 bracket x squared minus 1 all over x plus x to the power of 4 plus 2x squared plus 1. Oh, it like you multiplied it out. X to the power of 4 plus 2x squared plus 1. I take it you took the x squared plus 1 and you expanded it. I got something a bit different. Oh, okay. Danny, let's hear what you got. And you can, I know you don't mind using the microphones. If you want to tell me what you got and how that's different from what he has. Okay, well, it's actually the same thing if you think about it, because when you take minus 2 times the x squared, you're going to get minus 2x squared from that. I'll just put that over here. In both cases, minus 2x squared. And then you're going to have 2 times 1, which is plus 2. And that's what you have with this one as well. So that's minus 2x squared plus 2. And you got minus 2 over x squared plus 1. That's quite different. I got the same as Taj, except I didn't expand the x. Right. Yeah. And Anika, by the way, I actually think it's probably best to keep it in the factored form rather than expanding it. I would have kept it as x squared plus 1 all squared. For me, that's what I would have done, right? Let's see now. Can we go how we got that? We can. We absolutely can. We absolutely can. We will in a minute. But I just want to point out that Danny's answer and Taj's answer are actually the same, right? If you just multiply out the top, then you're going to get the minus 2x squared plus 2 here, and the minus 2x squared plus 2 from both of them. And the denominators are identical as well. You got something a bit different. Oh, no, yeah, you said that before, and yes, and we got what you had. And Ariana wants us to go over it again. Okay, so we'll do that. We'll do that right now, Ariana. That's fine. But I just want to point out that both Taj and Danny are on the same page. They're actually on the same page with just a little different way of expressing it. But let's go through it. We'll get to the tangent later on. Hopefully, some people already have that tangent line equation ready to go. But let's just go through it step by step, Ariana. So remember, this is what we're looking at here: 2x over x squared plus 1. So we're going to go ahead for dy dx. I'll do it in steps here. And we're going to differentiate the top, which of course is just 2. Right, Ariana? The top is just 2. Isn't that true? Yes, the top, when you differentiate the top. Okay, so that's equal to 2 times the underived denominator, x squared plus 1. All right? So nothing done to the bottom, just did something to the top. Then we're going to minus from that the derivative of the bottom, which is 2x, multiplied by the top, which is also 2x, by the way. All right, let me just make sure I'm doing that right. All right, so the root of the bottom, which is 2x, multiplied by the top, which is already 2x. So there we go. That's the top part right there. And all of that, so far so good, Ariana, by the way? So far so good? Are we good with what we does? Okay, all of that is over the x squared plus 1 all squared. Again, all you do is you just leave the denominator underived and squared. So we just have some tidying up to do at the top. All right. Again, the truth is that both Danny and Taj, they expanded it and they simplified and all that. The truth is that we really didn't have to do that, because the fact is that you only need to use it to find the tangent of the line, the tangent line. So we really could have just used the equation in its current form. But let me just keep going here. So that's 2x squared plus 2 minus 4x squared, basically. So minus 4x squared. So what I'm looking at here is minus 2x squared plus 2, which is exactly what, who had that now? Well, they factored it, so we'll factor it as well. Minus 2x squared plus 2, and that's all over x squared plus 1 all squared. And what they both did is they factored out. In one case, one person factored out minus 2, so that leaves you with x squared minus 1. All right, which is what I think this first version was the version that Taj had, and that's all over x squared minus 1. Yeah, x squared minus 1, and then x squared plus 1 all squared. And in the case of Taj, he actually expanded the denominator. Ariana, does that kind of work for you, what we just did? Okay, great. All right, so either way we put it, we're still getting the same result. And the question now, of course, is, well, what about the tangent of the line? What I want you to do for me now, Zach, is to put 0 into what I just put the check mark beside and evaluate the function when x is equal to 0. So plug 0 into that derivative, that thing I just put the check mark beside. Put a 0 into that and tell us what you're getting when you plug 0 into this. So you're just making a substitution, in other words. Make sense? Does that make sense? Perfect. Okay, go ahead, do that, and come back and tell us what that number is that you're getting by plugging 0 into the derivative. When you have it, just put that number into the chat, please. So anywhere you see an x, you plug in a 0, and then you're going to evaluate this thing that's there on the smartboard. Great. Great. I think everybody would agree with you on that. So the f prime of 0 is equal to 2. So this, yeah, so Anika is agreeing with you and Kushi is agreeing with you as well. So this represents the slope of the tangent line. That's what this is, the slope. Thank you, Zach, by the way. Slope of the tangent. But the other thing we need to know is what point are we going to use on this tangent line? So Fernando, let me go to you now. How can we find that point on the tangent line? Can you give me an idea of how to do that? Fernando, over to you. Are you there with us, by the way? Perfect. How can we find a point on this curve? What do we do to figure out that? Because when we're trying to find a tangent line, we need a point. We have the slope is 2, but we need a point on the tangent line. Any suggestions as to how I might be able to do that? Put it what? Meaning what number we're putting into the original equation? The 2? Wouldn't be the 2 though, because the 2 is just the slope of the tangent, right? But that wouldn't be, that's a slope. Put in the 0. Yes, exactly. We put the 0 in because we're trying to get a point on the, remember, let me go back up and show you the question again, right? That 2 is not representing a point at all. It's not an x or a y. What it is a slope. What we're trying to get is the equation of the tangent when x is 0. So really we should be putting 0, as you said, in the original equation. So could you put it in the original equation and tell me what the value of the function is when x is 0? What is the value of the function? It is 0. Perfect. So you know what? This function goes through the origin is really what we're saying. All right, let me put that at the bottom here. So 1 point on the line, the f of 0, as you just said, is 0. So a point on the line is at the origin, 0, 0. That makes it easy for us. Because if it goes through the origin with a slope of 2, right, that tells us immediately what the equation of this line is. Okay, anybody, can I throw this out to the class now? So the equation of the tangent would be what? If this thing is going through the y equals 2x, there you go. So the equation of the tangent is, there's no y intercept, right? If you look at what Adam and Anika and Sarah and Taj and Ashran and Tomalea all said, y is equal to 2x is the answer. We're done, right? There is a y intercept. I shouldn't say there's no y intercept. The y intercept is 0 because it's going through the x-axis and the y-axis at 0. So y equals 2x is the equation of that tangent. Okay, assuming that a lot of you had that answer from before, can we move on? Unless there's anything else anybody wanted to ask, we're gonna move along. Okay. Different kind of question. Determine the coordinates of each point. So it looks like there may be more than one. The coordinates, I need x and y. Each point on the graph of this function that they just gave us where the tangent is horizontal. Where the tangent is horizontal. So that would suggest that we probably need a derivative again. And because we want a horizontal tangent, we want to know where that derivative is equal to 0. That's our goal. That should be our goal. So let's go through the process. Again, this question could be tackled, just so you know, this question could be tackled using the product law. Or we could use the quotient law. I mean, I'm going to go with the quotient law on this one, but we could use the product law. You know, we could rewrite this by multiplying by x to the power of a half, but I'm going to leave it as it is. Okay, so here we go. let's start off with the f prime of x. All right? In fact, everybody, go ahead and write down that derivative for me now on your own. Go ahead and write down the derivative of the function. For that function that we have, we've done this a couple of times. I'm going to suggest use the quotient law, but you don't have to use the quotient. But try to simplify it as much as you can, because in this case, that might actually be necessary because you're going to set it equal to 0. And, sometimes if it's in like simplified, like factored form or whatever, that might actually be useful. So everybody go ahead and give me a derivative for 2x plus 8 over the square root of x. Go, everybody. So x minus 4 over x square root x. I'm going to write down what Sarah has. X minus 4 over x root x. Okay, I'm going to write down. Both of you are on the same page, by the way. I'm not going to put this as being wrong because you could probably be right. So x minus 4 over x times the square root of x is what I am hearing. Okay, so Ashvan and Sarah both have the same thing. Is there anybody else who either A agrees with them or B has something different? Right? Is anybody going to jump on the Sarah and Ashvan train, or you're going to be on a different track and you want to share with us what you have? Anika says she agrees with them. Okay. Got the same thing Kushi says. Okay. Okay. Anybody else is getting the same thing or something different? Is there another answer that's different from that answer? Or do we just need to go through it as a class? Is that what we need to do? Just to make sure, can we go through it? We certainly can. Okay. All right. I'm going to agree with this answer, by the way. But we'll go through it. We'll certainly go through it. So 2x plus 8 over the square root of x. I'll put that down here. 2x plus 8 over the square root of x is what we're trying to differentiate. So dy dx, I'm going to use the quotient law. I'm going to use the quotient law. Okay, so dy dx is equal to the top differentiated, which would be just simply 2 times the square root of x. All right, minus, excuse me, and of course, I'm differentiating 2x plus 8 to get 2, and I'm multiplying that by the undifferentiated denominator. I'm going to minus from that. Now, this square root of x, remember, means that it's x to the power of a half. So I'm going to say that if I differentiate that, it's going to be a half of x to the power of minus a half, okay, multiplied by the 2x plus 8. And all of that is over the square root of x squared. Okay, so before we do any simplification whatsoever, does that make sense? That's the thing I want to make sure that we're okay with. Does that so far make sense? Okay, perfect. So I'm going to continue by doing the following. I'm going to say that's equal to 2 times the square root of x. And then I'm going to say minus. Now, this is all going to be over. By the way, this denominator here is just x. Hopefully, we can agree on that. Square root of x squared is just going to give me x. So let's just do this. Can you go up a bit? Okay, sure. So I've put the derivative of the top, which is going to be just 2, times the underived denominator, which is square root of x, minus the root of the bottom is going to be half x to the minus a half multiplied by the underived top, which is 2x plus 8. Okay? All right. Now, hopefully we can agree that the bottom of this is just simply equal to x. When I square the square root of x, I should just get x. So here now we're going to have 2 square root of x, right? And we're minusing from that. I'm going to sort of change up a little bit. I'm going to put a denominator of the x to the power of a half, or the square root of x, if you like, with a 2 here. And I'm going to put 2x plus 8 on top. All right. And, oh, by the way, you asked me to go up a bit. Did I do that enough? Did you get all of what you needed to get there, Danny? Or how far did you want me to go, by the way? Okay. Okay. All right. Good. All right. So this is how I'm choosing to write this. So 2x plus 8 over 2 times the square root of x. And all of this is over x. How did you get, okay, let's just see. How did you just do what you did? Okay. All right. This is a half here. So it means that the denominator is 2, the numerator is 1 on this line right here. Okay, Taj, that's the first part. Yes? This can be written as a denominator because it's x to the minus a half. So instead of saying x to the minus half, I'm going to put 2 over essentially x to a half, which is the same thing as the square root of x. All right? But I'm going to leave on top the 2x plus 8. 2x plus 8 was already a numerator. Let's leave it as a numerator, is what we're saying. Does that make sense so far? So far, so okay, good. So what I'm going to do is I'm going to put this over 1 because what I eventually want to do is to find a common denominator for the top of the function. Sorry, yeah, for this top part of the function, for this part up here. And I'm going to think that a common denominator probably will be 2 root x, right? Between these two denominators here, between this denominator and that denominator, 2 root x seems to work. Okay? And all of that is still over x, by the way. Yeah. This is a lot of this is sort of some fairly involved algebra, just sort of trying to figure out how to do rational functions and all that good stuff. Anyway, so 2 root x is my common denominator. And I'm going to say what I multiplied this denominator by, the one I'm pointing to now, to get this denominator answer is simply 2 root x. So 2 root x times 2 root x would be 4x, okay, minus the other stuff that we had here, minus 2x minus 8. Now, I warn you, I'm saying I'm minusing both of these terms that were here. So it's minus 2x minus 8 plus 8. I thought it was 2x plus 8 before. Yeah, so it should be minus 8 in that case. No, Ariana, it would be minus 8. Because I'm minusing everything else on top. It's like saying, it's like doing this, minus 2x plus 8. So because of that, that minus applies to both of them. Do you see what I'm saying? Okay, I'm going to take back off what I just had there a while ago. So it would be minus 2x minus 8. And that's all over 2 root x. And of course, excuse me, we're going to run out of time today. So of course, I can first of all simplify the top of this to give me 2x minus 8 over 2 root x. I'm going to multiply that by 1 over root x. We've done something like this before, where we said that dividing by this means multiplying by the reciprocal. The top of this can be factored into 2 into x minus 4 over 2 root x times 1 over x. The 2's will cancel out. So what I'm left with is what somebody said earlier on, x minus 4 over x root x, which is, I'm pretty sure, what people had earlier on, x minus 4 over x root x. So I know that those steps are a little bit involved. I get that. But the problem is that it's not a case of us plugging 0 in this time. That's not what we're going to be doing. I'm just going to try to finish this up very quickly. The question is, this is the derivative. F prime of x is equal to this thing here. And the difference between this one and the one we did before is they're not asking for the tangent at some point. They're saying where the tangent is horizontal. So we need to set this thing that we have equal to 0. Right? This has to be equal to 0. We have to solve this so when x is equal to 0. Now, you might remember this from rational functions. When you're trying to solve a rational function equal to 0, really you're going to be looking at the numerator. When is the numerator equal to 0? Because if you cross multiply this right now, the bottom of this side times the top of that side, you're just going to end up with x minus 4 equals 0. That's really what you're going to end up with. So therefore, the solution to this equation is that x is equal to 4. That's the point at which you have that horizontal asymptote. That's when the slope of this function is going to be 0, right? You don't have to look at the denominator to figure this out. You look at the numerator. How do I make the numerator? In fact, you don't want the denominator to be 0, because the denominator being 0 is going to make this thing undefined. You just want to look at the numerator if you set it equal to 0 and solve for the numerator. And in this case, x is equal to 4. So the question was, what is the coordinate, or what is the coordinate of each point on the graph where the tangent is horizontal? We're just getting 1 point when x is equal to 4, but it also coordinates, we have to put that 4 into the original equation to see what the y value is. So it's going to be, so it's an f of 4, because that's when it's equal to 0, and that would be 2 times 4, is it plus 8, plus 8, divided by the square root of 4, which by my math is 8 plus 8, that's 16 over 2, which is equal to 8. Okay, so the coordinates would be, and I'll just stop on this note. I had one other question I wanted to do, but I'm just going to stop on this note. The coordinates would be 4x, sorry, 4 is the x, and 8 is the y. So that's the point. If I were to graph this, and if I had time, I would probably graph it to show it to you. That's the point where this function probably looks like it has some sort of a max or a min, or just a point where it has a horizontal tangent. Okay. All right. I know I kind of wore some of you out with that, but this will be on the video for you to review later on.